So MISCO, within the audio industry, people know that MISCO is a very advanced technological company when it comes to test and measurement and analysis of audio equipment.
Yeah, they're the North American distributor for clipboard.
Right, they have Workwind offices right there in their building. So they've got all of the most advanced equipment that you could imagine. Laser vibrometers and vacuum chambers and near field scanners, just all kinds of things that they can do. I didn't realize how advanced they were until we started talking about the Space Shuttle Orion and the speakers that MISCO made for the space shuttle. Mm-hmm. And that's a really cool thing for me, and to think about, and especially when I think about ToneSpeak and how a company that could make a speaker that would withstand the force of a space shuttle taking off.
Yeah, it's got to hold together, can't come apart and fly around.
Right, because speakers are suspension parts. I mean, they have 2 points of suspension that basically hold the thing together. Yeah. And they move air. That's what they do. They flop around, and to be able to withstand that is one thing, but to be able to measure that and actually tell you exactly what that's doing and how far that could go, it's impressive. Yeah, so for us, when we think about MISCO making the ToneSpeak speakers, I mean, you couldn't ask for anybody better to do that.
That's it. If you can design a speaker that can be accepted with all the compliance issues and everything, and for a space shuttle, and then design it to where it passes all those tests of a rocket ship taking them. I mean, a guitar speaker is a fairly simple build.
Right, right.
So I feel very confident that they can handle it.
Right.
That gives me confidence.
And they've been able to show us data from the ToneSpeak speakers that I don't think any other manufacturers ever really looked at.
Yeah, the equipment they have available, it just gets my wheels spinning about, because generally, in my past experience, it's very basic in design. It's learning. I mean, obviously you got to have the experience to know what goes with what, but really you just take a frequency response curve as a baseline, as how's this measured, tweak little things about that, but the end goal is to listen and verify it. And that still is. We're never going to not listen to it.
Right.
But it makes me think, I use this cone in this speaker, and I changed this edge doping over here. Okay, that sounds better, and I know what parts I can use to sound better. But we can use this equipment they have to maybe look at, why does this cone? Why does it sound better? What's moving around?
Right.
What's the material doing? Can I slow it down? Can I look at it with a laser? Just my mind's spinning with different
right.
ideas of how we can measure a guitar speaker more thoroughly.
Right.
Like it's never been done before.
I remember when Dan first sent us a frequency response curve of what we had built. He sent us 3 response curves, one on axis, 130 degrees, 160 degrees off axis, which I thought was weird at first.
I did too. Yeah.
I thought, why would you do that? And then I thought, well, since you can do that,
yeah, right.
How can I use that information? And so that even affects the way that I think about miking my speaker for live application, for studio application, when you're miking speakers to make impulse responses, all of those things, so that I know that a certain impulse response for the Liverpool on axis with a standard like a SM57 will do this. At 30 degrees, it's going to do this. At 60 degrees, it will do that.
It opens up a lot more thought process.
There's things that we hope to show people in the years to come, literally years, because there's so much data, to come show this to guitar players and studio people and say, look, with this information, we're gonna help you be able to do what you do better.
Nobody's ever published an off-axis response on a guitar speaker.
Never have.
And I'm like you, I thought it was weird at first, and I thought, we don't need that. But then you look at it from a mic perspective, like this could tell me how to perfectly mic my speaker when I'm in and even down to the room. Like if you know some of the environment that the room properties, you may be able to pick out a different miking perfectly for a room. Or like if you're in a band, we all know that when we're playing alone, we need a different tone than when we're playing in a band. Yep. You may be able to find that perfect response that you dialed in your tone at home. but now you're going to play with the band. So what response do I need to cut through the mix?
Right, that's exactly it. Because if you're playing in a band, let's say you're playing in a larger band where you've got a horn section, you've got somebody playing keys and organ stuff, and then you've got, you know, a couple guitar players, a drummer, you know, vocal, you know, all this stuff. And I need, when I go to my solo, I need to cut through all of that and be heard. Where can I best place that mic?
Yeah.
Most people think I'm going to put the microphone right here, about halfway between the dust cap and the end of the edge of the speaker, because this is going to be the best of both worlds. It's going to be kind of brighter, it's going to be kind of dark, you know, depending on how you do that. If I'm playing in a 3-piece band where it's electric guitar, bass, and drums, you know, I'm going to mic it differently than what
Absolutely.
I would in that large setting. So having that information already, I can see what it's going to do and kind of what it's going to sound like before I even get to the gig.
Yeah, and to your point, when you're playing with more people, more instruments, you might need a response that by itself it sounds nasty,
Right.
But it might work perfect in that setting.
When you start stacking up frequencies like a steel guitar, a piano, and you've got maybe somebody else playing a violin or something like that, you've got a lot of overlapping frequencies that you have to figure out which one of us is going to play here and which one of us isn't.
Right.
You know, so there's a lot of things to consider with all of that. Having the data helps you to do that.
That's exactly right. That's what you took the words in my mouth. Like before this, we're doing all this guesswork. We hope to take some of that guesswork out by showing you what it looks like.